Imagine a vast plain under a bright morning sky. 10 million curious children gathered in a perfect grid, each standing 1 meter from the next. They giggle and wink on a silent signal. Every one of them lets out a tiny, bubbly fart. Zero gravity, zero shame. Each child releases about 0.2 liters of gas in 1 second. Multiply by 10 million, and we get 2 million liters, 2,000 cubic meters, spill into the air in just a heartbeat. That sounds huge, but the air around us is already enormous. The plane they stand on covers 5 million square meters, 2 meters per child square. Spread that 2,000 cubic meters across the whole field, and the extra gas forms a layer only million and 4 meters thick in 1 second. In other words, the fresh gas mixes into the air so gently that you'd feel a breeze of only 0.0004 meters per second, slower than a snail crawling. But science loves to explore extremes. What if we trap the giggling crowd inside a giant stadium instead of on the open plain? Picture a stadium roof 10 meters high and wide enough to hold them all. The volume inside is 50 million cubic meters. Pour in 2,000 cubic meters of gas in 1 second, and the pressure jumps by just 0.004%, a tiny puff. Yet, in a confined room, even small pressure changes can create a breeze. If 20,000 people open doors at ground level with a combined area of 200 square meters, the extra pressure pushes air out at about 3 meters per second, enough to ruffle hair and tickle noses, but not to level trees. Now imagine a sealed dome with no exit. The internal pressure spike of 20 pascals will leave balloons and make your ears pop. The dome would bulge, then settle as the gas warms and mixes. But no gale would roll, because the children's farts are at the same pressure as the air around them. They merely add volume, not rocket fuel. Next, let's zoom in on the very instant of release. The farts collide in mid-air, like tiny soap bubbles. They create a network of gently expanding pockets. These pockets dance together, pushing air away in every direction. The speed of each pocket's wall moves at about 0.01 meters per second, barely enough to ripple grass. The result is a soft, playful ripple across the field, like the wake of a slow-moving boat. At last, we see the magic. 10 million synchronized farts do not summon a storm, but they teach us about volume, pressure, and diffusion. They remind us that even gigantic numbers can blend gently with nature. Our story ends not with a hurricane, but with a shared laugh and a whisper of wind, proof that science can turn even the silliest idea into a lesson in physics and keep our sense of wonder alive.